and welcome. This is an algebra video. In this video, we're going to be talking about proofs for equations. We are focused on pages 7 and 8 of your Algebra 1 Quarter 1 notebook. So we've got 4 properties, and you're going to see they all end with the same 3 words: property of equality, property of equality, property of equality. I do like to abbreviate, so I am going to write these as POE every time I refer to them in the work we do. Now, properties of equality. So these properties of equality, I'll write it out here, help us solve equations. And that is going to be our next unit, solving multi-step equations. So these allow us to solve. And I think once we read through it all, it will make a lot of sense. So the addition property of equality states that adding the same number to each side of an equation produces an equivalent equation, or an equation with the same value. So if A equals B, then A plus X will equal B plus X. So if I add X, I still have an equivalent expression. The subtraction property, very similar. If I subtract the same number from each side of an equation, it will produce an equivalent equation. If A equals B, again, we'll start there, then A minus X will equal B minus X. The multiplication property will not surprise you. So I'll just stack that up there really quickly. Sorry about that. Multiplying both sides of an equation by the same number produces an equivalent equation. So if A equals B, then A times X will equal B times X. And finally, my division of property of equality, dividing both sides of an equation by the same number, produces an equivalent equation. If A equals B, then A divided by X will equal B divided by X. Let's take a look at numbers 1, 2, and 3 and see which properties of equality, if that's what we're using, are being used. And note that in our other videos, we've learned about a lot of other properties: associative properties, identity properties, commutative properties, distributive property, inverse properties, symmetric, reflexive, transitive, and substitution. These are all together and can be used. So looking at number 1, I'm going to look at what changes between this first line to the second line. 5x stays the same, plus 2 stays the same, but I am subtracting 2. On the other side, I have 12, and I subtract 2. So you can see that I'm subtracting the same thing from both sides. This is the subtraction, and I'll just write the property of equality of subtraction. There it is. So our next one, I've got a lot of multiplication. I've got parentheses. That's normally when I want to look to see if it's going to be a change in grouping. Is it associative? So the 2 stays in the same place, the A, the 7, and the B. Everything's staying in the same place. And I can see my parenthesis in my second line is around the A and the 7. In my first line, it's around the 7 and the B. So this reflects an associative property of multiplication. Looking from step 1 to step 2 here, I can see that 3y and 9 are the same, but I am multiplying both sides by 1/3. So I have the property of equality of multiplication, multiplying the same number on each side. All right, let's look at number 4. David solved an equation as shown below. What property justifies the work between step 1 to step 2? So we need to look and see what change has been made. X minus 12, and we add 12. Negative 9, we add 12. This looks like a property of equality, and it's of addition because I'm adding 12 to both sides to get an equivalent expression. Number 5, which property of real numbers justifies the work below? So over here on the left side, same. Over here on the right side, I see parentheses, right? So is it associative? 12x plus 15, 12x plus 15. No, it's not associative because the same terms are in the parentheses. But over here, I can see 7x is at the end. And in the next step, 7x is at the beginning. So all addition, this is the commutative property of addition. Let's move on to page 8, and we're going to look at a proof, or 2 proofs on page 8, and see how can I use all the properties that I've learned to prove the solving of a multi-step equation. I start with 15y plus 31 equals 61. This is a 2-step equation, and that is a given. A given is where I start. It's given because it's what I was given. Let's look at my next, what happens in between step 1 to step 2. You can see that I'm adding negative 31 and adding negative 31. So this is the property of equality of addition. So the addition property of equality. In the next step, I can see I've added the 31, but I can also see here that 31 plus negative 31 results in a 0. So a number plus its inverse results in a 0. That is the inverse property of addition. When I go from step, let's say 1, 2, I don't know, step number something, from here to here, I see that the 0 is now gone, that if I add 0 to 15y, it equals itself. Anything, if you add 0 to anything, you get whatever it is, and that's my identity property of addition. My next step is I'm multiplying both sides by the same number. So that is the property of equality, and that's the multiplication property of equality. Now I can see that I'm multiplying a 15 by its reciprocal, and I'm getting 1. So a number multiplied by the reciprocal is 1. That is my inverse property of multiplication. And finally, 1 times a number equals itself. So 1 times y equals y. This is the identity property of multiplication. And I wrote these in purple and these in orange because I think these steps are going to be something you see frequently. When I'm trying to remove the addition subtraction part, a lot of times I'm going to go down this path where I'm subtracting or adding, which is going to result in a 0 because of the inverse property of addition. And then the 0 is going to, quote unquote, go away because of the identity property. Then when I want to get rid of the coefficient, I'm going to be probably multiplying using the inverse property and then the identity property. Okay, we're going to find all the mistakes in the following proof. We're going to identify and correct the mistakes. So I'm going to find and identify, which is pretty much the same thing. Well, the first step is a given, and I'm going to say check because, well, it was given. Let's see, symmetric property of equality. That says that I'm going to switch the sides, and it does look like I took the 8 to the left, from the left to the right, and the 3/4 x plus 2 to the left. So that step works. From here to here, looks like I'm adding a -2, adding a -2. They're calling it the inverse property of addition. I don't think we're there. I think it's the POE of addition. I think that I'm adding the same number to both sides. That's the property of equality. However, if I look at 2 plus -2 and get 0, there is the inverse property of addition. Additive identity property, the identity property of addition, that just means plus. Well, yes, If I add 0 to 3/4 x, I just get 3/4 x, so that works. Then I have the division property of equality. Well, I'm multiplying a number by its reciprocal, or I'm multiplying both sides by the same number. So I'm multiplying the same number on both sides, so it's property of equality and of multiplication. If I multiply a number by its reciprocal, I get 1. That is the inverse property. And finally, 1 times any number is itself, so that is the multiplicative identity property. So the 3 corrections are here, and that's it for this video. Thanks so much.